guess we're live now. Okay, we are live. Okay, hello guys. I am Puja. I am a part of C4. I am the research chief of C4, and also I recently took a mentorship program for IoT for C4 summer mentorship program. So today we are gonna be talking about Pytorch. So if you know even a little bit about machine learning or deep learning, you may know what Pytorch is, but many people think that it's something huge and they just don't even go into it. But I'm here to tell you that it's not that daunting on anything. So this is my website. If you just want to check me out and talk to me or connect with me, you can just go to catplotlib. I'm basically catplotlib everywhere. So let's get into it. Okay. So before we talk about PyTorch, it's important to know what is Torch. So Torch was an open source machine learning library that was built on Lua actually, and many of you probably use Lua, but for most people, for most beginners, they just don't know how to use Lua, and it can be a little bit complicated because learning a whole new language, which is not even that common, is like a waste of time for many people. So what the Facebook AI research development team did, also known as FAIR, they developed Pytorch, which is a torch but for Python. Am I audible? I didn't even check if I'm audible. Okay, I guess I'm audible. If I'm audible, can you just send a thumbs up or something? Okay, there's a lag. It's fine. Okay, so these four people, they were the core of the team who built the program, who built the library. So for folks who are from okay, you can hear me. Okay, thanks. So the folks who are from VIT, you may know who Shomit Chintala is. I don't know if I'm pronouncing it right. He was an undergraduate from VIT, so yay for us. And the rest of the people are just from a Facebook research development team. So why should we use PyTorch? I mean, there's TensorFlow is there already, and there are other frameworks. So PyTorch is different and better because one, it's based on Python, and Python is the most commonly used language for AI developers or deep learning developers and machine learning for all AI developers. And there's also a dynamic approach to it, approach to graphical computation. So one second. Okay, so if you have worked with TensorFlow, then you may be knowing that TensorFlow uses static graphs. So what static graphs do is that once you define a graph, you cannot change it on the go. But PyTorch allows you to do that. It uses dynamic approach to graphs. Dynamic approach to graphs, and so for static graphs, the user doesn't generally get to see what's happening in the backend, like what is going on in the GPU or in the CPU. But when you're using PyTorch, each and every level of the computation can be accessed and peeked at, so you can see everything that is going on. Also, it's imperative programming, so it means that you don't have to run the whole thing at once to see the computational results. You can just run one block of code and you'll get the results. So we will see that when we're on the hands-on session. And easy debugging, because of the dynamic graph approach, you can literally pick apart any piece of code and just debug it, because you can see everything visually. And there is always this comparison between Pytorch and TensorFlow, which I don't think makes a lot of sense. But people are obviously will be curious because they're pretty much similar. So these are the key differences. Pytorch was developed by Facebook, TensorFlow by Google, dynamic and static graphs that I told you about, and easy debugging. And TensorFlow actually requires a tool, a different tool for debugging. If I am not wrong, it's called it was called something TF debugger. I think it's called TF debugger, yes. So you need to download that, but for Pytorch you don't really need to do that. And again, for TensorFlow you have TensorBoard, which is one of the key features of TensorFlow, but Pytorch doesn't officially have one, but there is a visualize function, a function called visualize, which you can use to see what's going on, like your graph and to display whatever your neural network is doing. But the thing is, they're both open source and they're both contributing to the community, so I don't think they're just let them be, and there's no need to compare. If you want to use TensorFlow, use TensorFlow. If you want to use Pytorch, use Pytorch. They're both excellent technologies. Also, one of the I decided to keep this separate, this autograd function, from the rest of it, because this is very unique, and it will be better if we just go to Pytorch's official documentation to see what autograd actually is. Do I have any comments? Okay, no comments yet. Okay, so my phone keeps rotating. Okay, this is fine. Okay, so autograd, what autograd does is it helps you propagate your entire functions, like all the functions your variable has gone through. It will back propagate it and differentiate it, so which is like one of its kind, like first of its kind, because I don't think any other tool or framework allows you to do that. And so this is how you do it. So first import torch, and then this is, so doing this, you're just initializing a tensor with 1 1 1 1, and then you're doing an operation, so you're adding 2 to all of it, and so this is the output. And when you do this .grad underscore function, so you get to see exactly what operation was done to this variable y, so which is add backward. So at object, this is the name of the operation. So if you do more operations, and if you just they're doing z.mean to get like one variable, I thought, but no, I guess. So they're doing dot mean, and they're getting another function, the exact function, which is mean backward. And if you have to set required grade to true for you to access this. So this is another example. Required grad is true, and okay, this is sum backward because they're doing a sum on it. And then if when you use dot backward, so this is the key term. When you use dot backward, you can actually go back and see what the gradients were. So you get back this, which is like after doing all this functions and derivatives, you get that. So this is a pretty neat tool, I guess. So coming back to this, we are pretty much done with the documentation. Also, I have written a Medium article on this. Yeah, okay, so you can also visit this to know more about the documentation. It has a few more features that I did not mention here. So okay, so let's talk about the commonly used functions of Pytorch. So dot sum, these are simple. Dot mm, so dot mm is dot product. So when you have to suppose do a dot product between your weights and your features, inputs and your weights, so you can do this. And then dot random just generates random variables for tensor, mainly for testing or whatever, or weight initialization. Dot exp is for exponential. And then there's a very nice module nn that we are gonna that actually helps make neural networks so much easier. So dot linear is for linear transformation, dot sigmoid is for sigmoid, dot softmax is for softmax activation. So you can use these. And sequential is very nice because you just have to name one variable called model, and you can just put everything one by one after the other, and just your different layers. Suppose I'm doing a linear, then I'm doing a ReLU, then I'm doing a linear again, and ReLU and linear, and at the end softmax. So a sequential is really nice. And a loss calculation, you can have any of these three that I know of. I guess there are more. So one thing that I should mention is that I know all this because of a course from Udacity called Intro to Pytorch. It is amazing. I highly recommend it. It will take a few days, I guess, for 7 to 10 days to fully understand it, but you will not regret doing it, and it's free, so why not? Autograd, we just talked about it, and loss.backward is the key function that helps you achieve that. And yes, you also need to do this because it carries over the gradients from your each batches. So after you're done computing each batch, you have to do this. You have to make sure that the optimizer is 0 again, so that you don't get weird results, which we do get a lot in deep learning. Okay, so let's get coding. Okay, yes. So we are gonna make a simple neural network with only numbers. There's no pictures or anything because it's a little bit difficult if you're a newbie, but maybe we will go into that as well. But let's just start with this. So firstly, you have to import Torch. You have to also pip install Torch in your command line, which I already have. You just have to, okay, I'll just show it anyway. Just do this. Torch, I guess. I don't remember what's it called. Okay, let's just look at the documentation. Install Pytorch. I also highly recommend using Anaconda. It's a lifesaver. Trust me, it saves you a lot of trouble. Yeah, okay. Pytorch. Just do this and you'll have your Pytorch installed. This is for Windows. I guess it's similar for Linux and Mac. Okay, getting back to our code. I didn't change anything. So import this, and then we are just defining our activation function, which is gonna be a sigmoid. So 1 by 1 plus e to the power minus x, that is it. And where x is our output, and then we are just generating some random elements for weights and features. So this is very interesting. Torch.rand n 1,5, when you define 1,5, it will have a matrix of 1,5, and then you want, suppose, another matrix, and you want it to be just like features. So you have a very neat function called rand n underscore like, so it will have the same dimensions as features. And for bias, we just want one variable. And when we print these, so this is our tensors that we got. This is for features and this is for weights. Features is on inputs, by the way, and this is our bias. So let's see what our output is. So we will multiply our inputs with our weights, and we will add bias to it, and then we will have a sum of the whole thing. So torch.sum, you can use this, or you can use just .sum to achieve this. It will give you the same results. What is this? Okay. And also there is another function called .nm, which does the same thing, which gives you the dot product, like I mentioned in my article. I didn't mention it, right? I thought I mentioned it. Yeah, okay. .mm. So .nm actually, so this is a typo. Okay. So you can use that. To just do it in a single line more neatly. But the thing is, you have to change your you have to reshape your weights matrix, because if it's 1,5, then you cannot just multiply those two, right? So .view, you can use .view function to reshape your matrix. Okay, no, okay, fine. And then if you just print it, this will be your output. Okay, so if you want to do it more neatly, this is a mini neural network. So you have to you have to set the seed so things are more predictable, and then you define your features in the same way, and then you can say your input is something, and then your you have two hidden layers, and you have one output unit. So you can just substitute these and declare your weights, weight 1 and weight 2 for 2 weights, and then what is this? Where is it coming? for 2 layers and 2 biases. And then you run it through the activation function and this is what you're gonna get. So this is a very neat neural network with using Pytorch. We can actually go deeper into this. Okay, so we can go deeper into this, and we can also work with image data sets. Let me open it up. So this was from Udacity, and this was the neural net. This was my first neural network, and it was a great explanation. But Pytorch is a little bit. It can be a little bit difficult if you haven't worked with it. So what we have here is the very famous MNIST dataset, where you give a digit, a handwritten digit, and your neural network just gives back the digit which it thinks it is. Okay, so we import the data sets first. We import all the library we need. NumPy is very important in Pytorch. Actually, Pytorch and NumPy go hand in hand. You can build on top of NumPy when you're using Pytorch. And then you download the dataset, MNIST dataset. So Torch Vision also has this datasets and transforms library, which is very neat. TensorFlow also has that. Then we see the image shapes and labels. So we have 28 cross 28 images, and let's see one image. So 3, this is a random, no, this is the first image. This is the first image, and we are converting it to grayscale just for convenience. And then we are declaring another activation function. It is sigmoid again, and then we are flattening our input images. So what is flattening? Flattening is, suppose you have 28 cross 20, a matrix of 28 cross 28, and you want to line it up in one big just one column matrix. So then we use that is called flattening, because it's easier to give inputs to your neural network that way. So using -1 you can actually do it. This is also a very nice feature of Pytorch. Just by using -1 you can do it, instead of writing the whole what is 28 cross 28, 700 something, I guess. Yeah, 784. Yeah, 784. So if you don't even have to know what is simple mathematics, you can just write -1 and it will take care of it. Does anybody have any questions? Am I going too fast? Okay, I'll wait for 5 minutes, I guess. This was our basic neural network, which is, I guess, easier to understand. To the screen. Okay, I guess no questions. Then let's move on. After flattening the image, we are creating the weight matrices W1 and W2. And W1 will be W1 will be 784 comma 256, and then it will be 256 comma 10, because in the final layer we will only have 10 outputs. So we will create our biases accordingly, and then we will have our output. So we just talked about this in the last code. So when we do this, so we see that the network is not really trained yet, and we are getting ambiguous output for everything. So what we have to do is we have to train our neural network. So how do we build networks using Pytorch? Okay, so we will have to do linear transformations, and we have to pass our variables or layers through activation functions. So first we declare our hidden layer, which will go through linear transformation, which is 784 comma 256, and then we will have our output layer, and we will declare sigmoid and softmax using the NN module, which is amazing. And for softmax we have to declare dim equals to 1, which signifies that we are doing it for the columns, not for the rows. And then we just pass our input tensor to the various layers and activation functions. So there is also a module called functional, which we can declare as f, that is the norm, and it pretty much does the same thing. These are the various activation functions that you can work on. So this is our neural network. So we have 784 input layers, which is the 28 cross 28 matrix of images, and then we have our first hidden layer, which will go through a ReLU. Then we will have another hidden layer, which will also go through ReLU, and we are decreasing the size as we move on. And then our output layer will have 10 layers, and then that will go through softmax, and it will give our output. So this is just the same thing, but using f.ReLU. F is also very nice, and NN is also very nice. It depends on you which one you want to use. And then we just forward pass the network and classify our image. So it still doesn't know what an image is, and it does not classify it properly. So what we will do is we're gonna use nn.sequential, which I talked about, which I had written in my article. So this is very nice, very compact. You just define your input size and hidden sizes. So I have two hidden layers, so I'm writing 128 and 64, and you can also add more to it. So you don't have to declare them one by one. This is very nice. You can do it in just one variable, and this is my output size. Okay, so this was just the declaration of how we will do it, but we haven't trained our neural network yet. So to train it, we will see the other notebook. So training neural networks. So here is where we are gonna be using autograd, and backpropagation. We will be using backpropagation as well. So this is the mathematics behind it. I guess you can look it up. I don't want to bore you with this. And we will also calculate the losses. Like that's why we are training it. We've already done this. Okay. So loss. Okay. So we declare our sequential model .nn sequential model, and criteria is the variable that we will associate with our loss. So we are using nn. We are using an LL loss here, and then we are flattening our images, and then we're passing our images, and then we are just calculating the loss. So after you run this, you'll see that this will be your loss. So now autograd comes into picture. We've already talked about this. This is how it works. And now we are going to be using our loss and autograd together to find an optimal solution to our problem. Okay, so before we actually use the backward function, so which is the autograd mainly, this is what we have, and after using the backward function we get this. Okay, so yeah, it shows that it's working. Now we train our network. We are using an SGT optimizer, and then we are doing loss.backward. And this is the autograd working right here. Okay, now when you run this, you will actually be getting the training loss, because we are printing the training loss right over here, and it will take some time, and you can change your epochs to more to get better values. So now when you use matplotlib to display your image, you will get something like this. So yeah, it is training properly, and that's how you use Pytorch to classify image dataset. Does anybody have any questions? I guess there's a lag. Yes, TF is so the question is, which is faster, TF versus Pytorch on GPU? So TF is obviously going to be faster because it uses static graphs, but you do not get the flexibility of Pytorch in TensorFlow. But in terms of speed, I guess TensorFlow will be faster. Yes, there So the question is, are there any web frameworks that run ML algos and top suggested courses? Yeah, there is something called TensorFlow.js, which is not Pytorch exactly, but this is a very nice JavaScript program for JavaScript developers who don't really know a lot about machine learning but want to incorporate that in their in their websites. I actually did have a website. I did make one. I don't remember the URL now. So yeah, so this is a very nice that you can use for web frameworks. Yeah. Did have a Heroku app. I don't know what the URL is. I'm never gonna find it. Okay, any more questions? Okay, I forgot to tell that how it actually works. It actually works on WebGL. If you know what WebGL is, that is actually used for showing various graphs and all for graphics. But what TensorFlow.js is that it uses WebGL to do mathematical matrix calculation, which would be required for machine learning algorithm. Any more questions? Okay, I guess we can wrap it up then. Are the Jupyter notebooks? Yes, the Jupyter notebooks are actually available publicly. You just have to go to udacity.com. And in this course you will see that somewhere over here, yes, yeah, you can download it from somewhere over here. So they will tell you how to download it, and I highly recommend doing this course. It's really good. Yeah, sure. Okay, I don't know how do I send the link. Okay, someone from C4 will send the link, share it with you. Yeah, I guess we can wrap it up then. Thank you for attending. This was my first webinar, so I was a bit nervous, but I guess it went okay.